Hi, everyone. I'm Akanksha, and I'm part of the marketing team at Delta Q Technologies, a Zappy Group company. I'd like to welcome you to today's session. Please remember that this session is being recorded and will be available to watch on demand following this session. If you have any questions during the session, which will be answered during the live Q&A portion towards the end, please add them to the Q&A tab, which you can find to the right of your screen. Note that your questions will be sent privately. With that, I would like to introduce today's speakers for this session. I'd like to welcome Tom Wynn from Inventus Power and Nick Gunati from Arovi, presenting from battery data to adaptive performance, unlocking new ROI opportunities in electric vehicle fleets. Welcome, Tom and Nick. Please take it away.
Thank you, Akansha. Hey, good afternoon, everyone. My name is Tom Nguyen. I'm the VP of Business Development, also responsible for our product strategy at Inventus Power. A little bit of background of Inventus Power. We are a leading battery manufacturer for advanced solutions for portable, motive, stationary applications across a wide range of markets.
And my name is Nick Gunati. I'm founder and CEO of we're a software technology company, primarily working hardware company to launch what we call hardware. So the basis of today's talk will really be focusing on how connectivity, really this foundation to unlock business. And the key aspects of this are really in delivering over-the-air updates and maximizing your battery. Of course, we have one of the leading lithium battery companies here. This will speak more on how we can translate this in vehicle level. So what is connectivity? I think we've heard this term thrown around for many years. Sometimes ultimately, connectivity, when we talk about this, refers to the idea of being able to access your machine data in a real-time. So this is typically accomplished through some sort of cloud-based ecosystem where we're pulling sensors that capture machine data, putting it on sort of gateway, and sending that data into the cloud. In the next slide, Tom, you see that electrification is actually very closely tied to connectivity. And across industries, construction, professional cleaning, material handling, other industrial equipment, there's a factor of electrification that enables getting the actual data from the motor controllers, from the battery, that makes it more seamless to pull the actual raw data from as opposed to derived data, say, from a combustion engine. And so this McKinsey study looks at the expansion of electrification over time, and there are other related studies that look at the expansion of connectivity over the last 10 years and forward-looking. And so the thesis here is really that electrification will continue to drive more connectivity opportunities. In the next slide, Tom, we're really talking about why connectivity alone is not. And we frequently talk about what we call this great IoT craze of really in the 2015 frame. We saw the of a lot of sensors, all sorts. So OEMs being able to harvest the data from field assets, whether they're in the industrial space or the telematics became a standard. And so being able to access this raw data was a huge win. The problem was that at some point we got to the scenario where there was actually more data than the value, right? So having the raw data and alerts is useful, but that assumes that there's human loop to do something about that data to react. Now, this poses a real challenge because at this point in 2026, we're facing a reality where companies have a large data of field data, and in some ways are struggling with this amassed amount of data. But at the same time, ironically, are struggling with processes and challenges with the different aspects of the organization that would really benefit from utilizing that field data. So what we're discussing today is really how to close that gap and utilize that field data to deliver value. And really, we pose a question of how does connectivity translate to this value? So, Tom, if we go to the next slide, it's really about the or being able to leverage data in experiences that provide ongoing value. This may look like web and mobile experience to continue to enhance the product and complement the hardware with the software. It's developing that stickier relationship with the customer. So understanding when field failures will occur through proactive maintenance, but we also pose informed reactive maintenance. So when the system breaks, we know exactly what's going on, and we can reduce much quicker. And then on the concept of developing recurring revenue, I think being able to provide this ongoing value provides an opportunity for these OEMs to offer recurring revenue software opportunities through that can access high margins that are well beyond what's typical for hardware. And a real cornerstone of this is the ability to deploy or software upgrades that make hardware better. And this is really around what we're talking about with regards to over-the-air update or OTA. The idea of closing the loop from gathering the field data to then pushing these updates. So I'll hand it over to Tom to talk about what this looks like.
Yeah, thank you, Nick. So as we kind of look at obviously battery intelligence, there's software, there's amount of software that's encompassing in the battery technology itself. When you look at characterization and how that feeds back into telemetry, obviously sensor data and then machine operation. As Nick mentioned, the goal is how do we automate this process and flagging in real-time information, anomalies and underperformance of the machines, and then being able to kind of properly notify service team members ahead of schedule, right? And whether that's done through the proper firmware patches. As you know, lithium-ion batteries and battery technology, the more you utilize it in understanding different corner cases, you understand there's certain conditions that it is deemed to operate. But obviously there's firmware improvements and being able to excel into improve life and obviously improving performance. And so sometimes the firmware, obviously, as we look at updating that, loading that to the cloud, but obviously refinement of that through diligence and testing in the field. We want to make sure that the closed loop process is followed so that we can kind of stage that the over-the-air updates in time and making sure that's compatible with the hardware and obviously through the proper integration. So when you start looking at enabling operators with patches and improvements, you're trying to make it a seamless transaction, but be able to do a wider rollout and be able to monitor the performance of the entire fleet. So that's where we can start verifying kind of more of the resolution in real time with this OTA scenario. When you're looking at also the battery over-the-air updates, we're trying to drive more value creation with our customers, right? That's ensuring consistent fleet behavior. When you're looking at all the fleets, sometimes there's a settled improvements of firmware updates, but you also have to ensure that reliability in confirming to the proper workflow, right? The goal is, as we're doing doing the testing, how do we continue looking at continuous improvements, better performance, whether it's on battery behavior, charging behavior, system behavior, right? And then obviously being able to validate that. Once you build upon that, now you can kind of create an architecture and then obviously using that as a baseline to develop future vehicle architecture. That is very similar to how automotive is following today. And really, when we're looking at obviously over-the-air updates, it's really a best practice, or it's a great tool to kind of deploy, scale that, and monitor it across the board, giving it a proper rollout, giving it the best visibility across the site locations, and then understanding the post-release of monitoring, right? What does that mean from battery behavior? Have we looked at the health of it and the characteristics, or do we feel that the battery performance is, in some cases, over-engineered for some of the applications that are used in the field today, specifically around the industries that we've been discussing? Significantly, when we look at over-the-air updates, there's obviously our goal, and that I'm going to show this as kind of like a case study. You know, today, right, when we look at today, you know, if there's a battery deployed in the field, an operator notices a problem, they do have the contact service. Contact service, reach out to Inventus or to the suppliers. And then you start doing your diagnostics. So that's a procedure that historically has been done. But really, when we're looking at OTA, how do we gauge that? How do we kind of look at a patch and how we do a refinement and do that much faster, reducing this by a quarter of the time set. So, you know, if we're looking at kind of over their updates through battery analytics and monitoring, now you detect the problem, obviously escalating to engineering and then streamline the analytics. You can look at service history, data, you know, traceability across the board. And then when we look at some of the case specific scenarios, we can kind of invest in a proper software patch. Again, the software patch can be for improvement, performance, or if it's, you know, most likely, if it's not related, it's most likely going to be related back to performance improvements. Obviously, we can develop patches for safety scenarios as well, in a safety net. But really, the goal here is to kind of reduce the timing and accelerating that when there's a scenario to validate a proper warranty claim. So that's where we kind of work with our OEM partners to kind of initiate these fixes through the proper integration aspects of it. And you see the results from the time savings across. When we're looking at battery signals, right, we're trying to look at the hypothetical scenarios of battery signals and trying to convert that into real business outcomes. So there's fleet-wide performance intelligence, all of the battery behavior across the entire fleets. We're trying to understand all these, you know, corner cases, right? You pick whether it's related back to overcharging, imbalance, drifting, shelf life, you know, regenerative current at different weather patterns. You know, that's all refined based on duty cycles and environmental conditions. But the goal of understanding to the cloud and connectivity is the early detection through what we've already analyzed, right? We've taken kind of the best of that emerging issues and trying to optimize that performance before they even surface. That's where on software data, right, we want to be able to kind of convert that raw data into true, clear signals, right, and do the proper updates. And so therefore, as you look at deployment, you don't have to kind of look at your investment as your in-house battery specialist. We're kind of acting upon that to kind of give you making the decision process much faster and also abiding through safety regulations as well.
And when we look at those signals, we can see the direct business outcomes of those specific inputs that we're monitoring at the battery level, right? And I think where we're at today versus where we can go is really thinking about what are the aspects of this reactive to proactive nature that can be automated. And this is a great case study of where agentic AI can provide real value, delivering real outcomes, right? We've heard agentic a lot, especially recently. But when we think about the key outcomes we're after, whether it's uptime, so being able to prevent unscheduled maintenance, cost reduction through that reactive nature, and then also looking at the service time. The state that we're at today with the levels of alerts, the battery data, other system data that's going up through the can, as well as enterprise data, still requires a human in the loop today to process, add the context, and deliver the outcome. Where we're going is being able to assign specific agents to field those alerts such that your service technician isn't fielding 350 faults of the same nature. We're instead placing an agent in between the raw data and our service teams. And so this ideally will help to increase productivity, increase the proactive nature of what we're able to deliver without significantly increasing. And the key thing that I think AI is very good at doing, beyond what humans in the loop can do today, is understanding a wide mass of unstructured enterprise data, whether that's through the CRM, understand when the system was sold, the services platform, to be able to and to understand the failing conditions or the user identified condition, to then inject that context into the field data with the connectivity to then provide these actions to deliver enhanced uptime, reduction in cost. And a key aspect of this is unifying this data into a data fabric. And at Arobi, this is one of the pillars of what we do. So when we engage with a customer, it is really around understanding where this data sits today and delivering what we call this unified data fabric to then break down the silos or the air gaps between data, the enterprise, the rest of the enterprise, whether that's through custom dashboards that certain users are using, or the CRM, the PLM, different aspects or containers where this data may live.
Now, as we kind of talk about integrating software ecosystems, I mean, this is kind of, as Nick referred, us Inventus having kind of that agentic AI being the battery intelligence, being able to understand the software, understanding fault conditions, understanding the scenarios of how the battery performs in different conditions. We provide that analytics and API that into the OEM cloud. And really the goal here is to be, this can be a gateway of being agnostic two different ways, through an Inventus gateway, through the hardware and telematics, or through, being universal to the OEM's existing hardware and being able to unify that information, right? Data from all the battery systems, sensors, and motors, and consolidating that. But taking that a step further, right? Not to confuse anything, but how do you unify all this information, even providing that dashboard, do the proper integration to your end customer, obviously controlled by a lot of the rental companies. You can create, obviously, their own dashboards and unifying the information. The relevance of the information here is to kind of simplify that, but through proper analytics and usage, right? This can kind of give the whole battery index through a three-stage approach here, right? Without complicating it, but obviously leveraging existing hardware architecture. So when we look at kind of case studies and some examples here, when we look at some of the observations that exist, and I'll kind of pick a case here from like material handling, most of the forklifts or lift trucks, the goal is you have a lot of these standard battery sizes, but as we, OEMs run testing, they see a lot of different anomalies, different performance, degradation, different outcomes. And so what the things that it's important, what battery intelligence enables is we can start analyzing proper use, proper downtime, if, applications or systems that are not being charged properly. Obviously, this can help assist on proper, better warranty outcomes due to root cause analysis. And really, the goal here is we're looking at kind of like the product design architecture. If battery systems are intended for and to work for all these applications, now we can understand and deep dive further on whether that battery system is actually truly designed for that, or if it's over-engineered. Now you can start investing into some VAV activity, right? Some value engineering aspects of it. But that's usually dependent on duty cycles and usage patterns. Because most testing has been designed today is worst case scenario in corner cases. But again, you don't understand the anomalies until you run the full vetting of the machines, which could take many, many years. So what battery analytics allows us to do is really to understand lifespans on different scenarios. Again, starts with environmental conditions, machine use, and then obviously the charging behavior, right? There's obvious cases of fast charging, opportunity charging, or charging, overnight charging as we speak. But this is where, again, the lifespans and the data helps us enable to make better decision process for this industry. Now we'll talk about another industry, healthcare, hospital medical carts. This is an industry that we've been servicing for over 15 years, right? And all you see today on the approach is, there's an expiration date on the battery. Just has to be replaced, just because. Even though many of these cards communicate, the hospitals don't care. They just want to make sure it's being replaced. That's why would you want to replace a battery that still has great shelf life, good performance? And so these are the things that we can obviously look at from intelligence, being more proactive, understanding the health, understanding the conditions, and obviously being in a safety, it's a critical environment, right? It could be life sustaining and whatnot. But basically, power and communications, we understand that these replacement stickers, we're really trying to refine this with more information to kind of give better uptime, more utilization in that scenario. So when we look at intelligence, again, understanding, minimizing replacement costs, but obviously minimizing downtime, right? At time, because these batteries are powering up dashboards or powering up different types of equipment, it really gives us kind of like a true trail of utilization across the board. And sometimes if it's not utilized, do we need to scale back on the battery sizing? So I think, these are two great scenarios to kind of understand, battery analytics based on, and, usage, but making better decision process, right? To eliminate warranty claims and replacement costs of the battery systems.
So of course we land at the question of how do we implement this in organization all the time, right? And I think the key aspect of this talk is there's probably a lot of gold inside the battery data already. And so implementing this advanced analytics and intelligence on top of that can translate into real outcomes, particularly in outcomes. But at a high level, when we're looking at how to implement this in an organization today, it really begins with understanding what are the processes that exist in place. Where is this field data? What are those core systems that the processes depend? And so unifying this field data, the other systems, and then being able to translate those signals to decisions, as Tom discussed on that table slide, where we're identifying those key things that we can see in data that directly impact the core value areas of the business is the key next step. And then to identify ways to implement technology, particularly AI, in a very safe and effective way, where we're putting it inside a box where it's executing at a high level, but also we're not giving agents to understanding the system boundaries around what are paramount for safety. And of course, just iterating. And then if we map this to really tangible steps, what this looks like in theory is integrating this data, whether that's a data fabric or a data lake or something similar, working with those teams on the ground, look like implementing and using eyes to continue to service and hydrate dashboards or workflows with richer data, and then iterating on those processes, adding automation. And of course, a key aspect of this. And so as you're thinking about building organizations, understanding key compliance areas that are frameworks for defining proper security and today AI security is so delivering on enterprise security, understanding trust, real time. You have dedicated on a regular basis as well. Are we building out the process in a way that's compliant with the certification? Are key questions that I would recommend. So I think the key takeaways here of this discussion is really around how to leverage this field data in a way that brings more business value. And so we discussed how connectivity is just not enough, right? In today's world, it's really translated data and real. We're posing the data really has untapped potentials for value creation, right? Especially in organizations that have large data. There is probably battery out there that can really indicate or hint at ways to improve. And building out a closed loop system to unlock this real value through OTA will enable you to deliver performance enhancements, ongoing value, and that customer stickiness by enabling your hardware to improve. And of course, we discussed this really at a high level, but we're happy to dig in more. The future is proactive. And how do we implement AI today with all of this amassed data? We believe is a huge. And with that, I'll hand it over to Tom for any last thoughts, but otherwise we'll open it up to Q&A.
Yeah, I think we'll open up to Q&A, but yeah, I think Nick kind of covered it. I mean, understanding what we're kind of building out for OTA updates and the better analytics aspects of it. This is a piece of the puzzle, right? To kind of complete a system and understanding analysis on, all and unifying all this data to a platform, right? Because anything that's becoming more connected is just really understanding behavior and use in the field. And our objective is to ensure that this is as seamless as possible, but tailored to everybody's usage. So, but wrapping up, yeah, we'll leave it up to any Q&A questions.
Perfect. So for the Q&A, if you haven't already, you can submit it using the Q&A tab on the right of your screen. And I will get started with some of the questions that we have. So there's a lot of talk about AI. What specific decisions are you comfortable letting AI make today, and what still requires a human?
Yeah, so I think that AI is certainly not without its faults. We've probably all experienced to some extent hallucination or inaccuracy, and going in clear-eyed with those limitations is extremely important. So, not allowing it to just go in, root access to machines and make decisions is a key. That's very obvious, not where we're. But I think when we think about what AI is really good at, maybe being able to pull in on data across the enterprise and provide that context to raw data makes it such that the service tech who's driving out to the site doesn't necessarily spend as much time diagnosing. Maybe they have more history of when was it delivered, what were the past maintenance, has this fault, have we seen this fault before at this particular unit, and then maybe been a challenge for the subfleet or even a region, right? And then reducing the time to back to uptime. So I think when we think about the limitations, also I think about the areas of opportunity, we really want to, as I mentioned, put it in a box where it doesn't have total control, and we're relying on ways that we really.
Perfect. And then as you move toward more automation and over-the-air updates, what's the biggest risk OEMs need to be aware of?
I think it's, it relates back to security, right? I think Nick emphasized earlier, it's like ensuring that, there's a lot of data that's out there. How do you ensure it's protected, right? And that it's not being shared to the public. So the premise of ensuring compliance, right? SOC 2 compliance, I look at that, for cybersecurity and all the measures, I look at that as kind of like the UL standards for batteries today, right? Ensuring that that is protected, you have the compliance, that's rolled out, and that obviously there's backup plans for that. But I'd say that's really the two key measures there. And it's not being used against your competition, but everything that we're developing and the technologies is unifying that to make it better for all the industries. But obviously, there's going to be a lot of different scenarios, but everything is catered, more customized to each of the OEM's dashboards and based on their application needs.
And I had a little color there, actually, right? Yeah. So what we're talking about in this discussion are really tools, but we can't rely on tools without great process, right? So if there's bad code that's shipped over the air to a device, do we have the process in place to back to stable build? And how do we respond, right? So when we're thinking about building out OTA inside an organization, it is just a tool. And we really do need to build out processes around it to make sure that it.
Okay, and can data integrate into existing ERP or fleet management tools?
Very much so, yes. I think as we discussed, right, like we're really thinking about how the field data should inject it both to hydrate existing systems in business, but then vice versa, using that enterprise context to make sense of the raw data.
And how long would it take to deploy a connected ecosystem?
That really depends on the scope, right? Depending on the data that's available on various technologies and how it's connected. The useful information, I mean, obviously to have a cloud system is having useful data, right? Useful information. And then you can kind of looking at those key metrics, the KPIs to apply that to a proper cloud system. What are you trying to deploy out to maintenance workers or internal use or external, right? Information in, information out. But that's, like I said, that's really dependent on that scope. But a rollout, Nick, your thoughts, timeline?
It really depends on where your organization is at, right? Like if we think about the 3 steps of data infrastructure, application layer, and extensibility through API, and then on top, intelligence, whether that's AI or proprietary models. If we think about these 3 steps, it's really about where you are. So if you spent the last 10 years investing in this data infrastructure and cloud, it will be much faster to implement application layer. But if we're in a place where we're not necessarily, that will take much more time to then build out the data infrastructure integrated to devices. If there's a field in on the devices field, and then implementing the intelligence solution.
And which cloud platforms are supported? AWS, Azure, private cloud?
The platform for intelligence is really cloud agnostic as well as hardware agnostic. So being able to deliver this level of analytics and capabilities really does not depend on what systems you have in place today. It's ideally when we're thinking about building this out as a concept.
And the last question that we have is how secure are over-the-air updates?
Nick, you want to take that?
Yeah, so OTA has been a concept that was pioneered many years ago through the software-defined vehicle, right? Automotive. So there are procedures in place to make sure that OTA is very safe. But again, it poses risk, right? Because we're not only reading data from devices, we're potentially writing new firmware onto. So there is a level of risk, and being able to build out the processes to securely push code that we know is good and the ability to quickly revert to a stable build are very important. So it's as safe as we make.
And that's also done through proper validation, integration and validation process, right? You're going to have an existing software base, and then you're adding on that layer into improvement. There's methods of kind of reverting back to the existing, but as Nick mentioned, there are some measures of areas that it has to be revalidated. But I mean, obviously the security measures of it being able to validate and apply it properly through the workflow is kind of like what we need to have in place and help educate that across the board.
Perfect. Are there any last comments, Tom and Nick, that you have before we close off the session?
No, I think thank you for your time, and thank you for everyone who's participating at this event. I'm glad that it's been very educational, and I hope that everyone has, if there's any questions, they can reach out to us for further questions on connectivity. But thank you for hosting.
Perfect. Thank you so much, Tom and Nick. It was a very insightful session. And we hope everyone enjoys the rest of their day. And be sure to attend our next session at 11 a.m. Pacific time and 1 p.m. Eastern time. You can find it in the lobby for the next session. So thank you, everyone, and enjoy.